Let's go ahead and solve word pattern. In this problem, we're given a pattern and a string s, and we need to find if s follows the same pattern. Here, follow means a full match such that there is a bijection between a letter in pattern and a non-empty word in s. So more specifically, each letter in pattern maps to exactly one unique word in s. Each unique word in s maps to exactly one letter in pattern. No two letters map to the same word, and no two words map to the same letter. So in example 1, we're given the pattern ABBA, A-B-B-A, and we're given a string dog, cat, cat, dog. If we map the character A to the word dog and the character B to the word cat, we notice that A, B, B, A, where A corresponds to dog and B corresponds to cat, translates to or maps to dog for A, cat for B, cat again for B, and dog for A. And if we compare that to our string s, which is dog, cat, cat, dog, then we return true. So before I code the solution to this problem, I kind of want to talk about how I thought about going about solving this problem before I basically type it out. So the first thing we're going to do is we're going to create two lists. The first list is going to store characters, and the second list is going to store strings. So in our first list, we're going to store the characters of pattern, but in both these lists, we're not going to store duplicate values. So basically, if I wanted to store pattern in my first list, the only characters I would store are A and B. I won't have A, B, B, A. Similarly, for my second list, that is going to store a string, I want to store the words of the string s that they gave us, and I don't want to store duplicates either. So dog, cat, cat, dog, I'd only have dog and cat in that list. Now quickly, before we continue with the next set of steps, I'm going to check if the length of both lists are not equal to each other. That means that we either have more characters than words that we can map them to, or we have more words than characters that we can map them to. And if that's the case, then we're just going to return false. Also, another thing that I'm going to check is if the length of our original pattern is not equal to the number of words in our string s, then also we can instantly return false. After that, what we're going to do is we're going to create a map that stores characters as a key and strings as a value. And we're going to use the map so we can map characters to their respective strings, respective words. Then what I'm going to do is I'm going to go back to our original pattern once we have our completed filled up map. And for every character in our pattern, we're going to retrieve the value of that character from our map, which corresponds to the value of that key character. And I'm going to compare it to obviously we're going to start at the very first character in our pattern. I'm going to compare the value of that key in our map, which is the value of the current character that we're on in pattern, to the first word in our string. So in this case, dog. If the value of this character, which is a key in our map, is the same as the word that we're looking at in our string s, then what we're going to do is we're going to look at the very next character and the very next word and compare them as well. If the value matches the word, then we're good. We're going to keep checking every character to every word. But if we stumble upon a character whose value does not correspond to the word that we're looking at in our string, then we need to return false. So with that out the way, let's put that into coding. Like I said, the first thing we're going to do is we're going to create two lists. List of character, we can call this P for pattern, which is equal to new linked list. And a second list that stores strings, we can call this words underscore list, which is equal to new linked list as well. Now what I'm going to do is I'm going to create an array of strings that is going to store every word in our original string s, because they gave us a string s, not strings of each word in that string. They just gave us one complete string. So I'm going to separate each word in that string and fill it up in our array. And the way we're going to do that is by doing something we've seen on this channel before. We're going to create a string array. We'll call this words, which is equal to s.split s plus. So this line may look a bit complicated at first glance, but what this does is if you have a string s which is composed of multiple words and you want to store each word in an array, in essence, this line of code takes a string s and breaks it down into individual words by treating any sequence of one or more spaces as the separator between those words. And by one or more spaces or white space characters is, for example, if we had dog, this is just one space, but if we had dog space, space, and then cat, it's going to treat it as one space, and we're going to separate basically the words by one or more white spaces, like I said. And how are we going to do that? Well, we're going to call the split method in Java. This is a built-in function in Java in the string class. We use it to divide a string into an array of substring based on a given pattern. Now, the pattern that we gave it is S plus, or rather \S plus. Now \S more specifically matches any white space character. The plus matches one or more white space characters. And that's the gist of this line of code. So now with our string array of words, what I want to do is I want to check if the original pattern dot length is not equal to the number of words in our string S. In that case, we need to return false. So if we have more characters than we have words, we're going to have a character that maps into nothing. And so obviously we need to return false, and vice versa. So now let's go ahead and start filling up our lists with unique values, no duplicates. And the way we're going to do that, let's start with the P list. For every character C in pattern dot to character array, to make sure we're only filling it up with unique values, we're going to have an if condition, and we're going to say if P doesn't contain the character C, which we're looking at, then to our list P, let's add the character C, which we're on. And let's also fill up our words list. So for every string word in our words array, once again, if words, or what do we call it? Yeah, if words list doesn't contain the word that we're currently looking at, then words list dot add word. Now let's compare the size of our two lists as an extra safety measure. So if p dot size is not equal to words list dot size, let's return false. Before we continue, we have a quick typo. This bracket actually belongs up here. So now let's create a map which is going to map each character to its respective string or respective word. So first and foremost, we need to create a map that stores character as its key and string as its value. We can call it map equals new hash map. Now let's go ahead and fill up our map. So for every int I, which is equal to 0, as long as I is less than p dot size, or words list dot size, they should be the same, I++, map dot put. So get the element in our p list at index I and give it a value of get the element of words list at index I as well. So if we had a list of unique values for ABBA and for string S, we're going to have a list P that contains A and B, and a list words list which contains dog and cat. We're going to map A, which is at index I equals to 0, to dog, which is also at index I equals to 0 in our P list and on our words list. And we're going to keep doing this until we run out of elements to process. Now what we're going to do is we're going to create another int variable called j or I, again, doesn't really matter, which is equal to 0. And what we're going to do is we're going to loop through the characters of our original pattern. So for every character C in pattern dot to character array. Now what I'm going to do is I'm going to go to my pattern. Basically, I'm going to process every character in our pattern. For every character that I'm on, I'm going to go to my map and get the value of that character, and I'm going to compare it to the word that we're looking at in our original string S. If they're the same, then keep going. If they're not the same, then we need to return false. So if map.get, the value of C, is not equal to, now remember, up here I created an array of string words which contains all the words of our string S. That's what we're going to be accessing in order to compare the value of the character to the word that we're looking at in our string S. Because remember, this is a string S and we don't have a method that checks for substrings inside our string S. So we're going to utilize our words array instead. So if the value of map.get character C, which we're looking at, is not equal to words at j, then return false. Otherwise, if they are equal, then we're going to ignore this if statement and we need to increment j so we can look at the next word in our words array or the next word in our string s. And if we successfully terminate from this for loop, we can just return true. So let me see if I can zoom out and display the entire code. There we go. So that's the entire code. Now all we have to do is submit and see if it works. So we just have a small typo. There's an extra bracket that I missed. Let's submit again. Accepted. So that was the word pattern problem on LeetCode. I hope you found that video helpful. I hope you found this problem not too complicated. And thanks for watching.